but it's still under functions. It's logarithms. The lesson is very easy, very short, but you have to concentrate because it's a new concept. To start with logarithms, let me first explain exponents. When we did exponents, like for instance, the bases are the same and we multiply. This one has an exponent of 4 and 2. What will that answer be?
2 to the power of 6.
Yes, 2 to the power of 4 plus 2, which is 6. Now this same concept we use in logarithms. When we did this, 3 to the power of 4 divided by 3 to the power of 1. What did we do? What did you do? Minus 1. 4 minus 1. So, when we multiplied, we added the exponents. When we divided, we subtracted the exponents. This we're going to use in logs as well. When you had an exponent like this, 2 to the power of x equals 2 to the power of 4. Now I said solve x. What did you do? Yes, you drop the bases and then you say x equals 4. What will happen if I say this? 2 to the power of x equals 3 to the power of 4. Okay, up until now you can't solve it. That's where logs come in. When you have to solve an exponent and the bases are not the same. That's where you get logs. Now first you need to know what the definition of log is and how to change from the exponential form into the logarithm form. The exponential form has different bases with an unknown exponent. When you change it into the logarithm form, it works like this. That log A, this A, is a subscript, and that is also the base with the unknown exponent. So these two are the same. This is a base A, and log has a base A. So these are the same. We want to solve the unknown exponent, so that is alone on one side of the equal sign. And this B stands next to log. Okay, let's look at another example. Let's say it's 2 to the power of x equals 3. That will be x equals log 2 base 2 of 3. Wait. How do you read this part? You say log base 2 of 3. That's how you read it. Or log 3 base 2. Okay. Why do we use logs? To get the exponential inverse, that's one reason. That's the log graph. Or to solve the exponent if the bases are not the same. Right. Now you have to turn to your log laws. Mine looks a little bit different, but it's the same information. Log laws. Okay. These laws you have to learn. You don't understand them, you learn them. Okay, the first law says, if we multiply two numbers, you can split the log into log x, the first number, base k, plus log y, same base k. If we divide two numbers, then it's log x base k minus log y base k. So you keep the same bases, but when you divide, you minus, when you multiply, you plus. The third law is when you have an exponent next to the an exponent on the number next to log. Then that exponent goes to the front, in front of log. These three log laws you use a lot. The next three you don't use so often, but you have to know them should they slip a 1-point question in the exam. If you have log p base k, but you want to change the base for some other reason, you can say it's log p over log k, and then you can choose your own base. So if you want to change the base, I don't want k, you say it's log p over log k with my new base that I want. Right. If you want the reciprocal of log x base k, it's 1 over, and then you swap the x and the k. If you have a fraction as a number, and you want to change that fraction into a number, you make the base a fraction. Okay. You don't understand them, you learn them. That's the rules.
Can you please repeat the fourth one?
Fourth one, this one. I want to change the base. I don't want to work with base k. I want to work with base 10. Then you change it to base 10 or base m, but then you say it's log p over log k with the new base. Okay.
Just can you give an example of numbers?
We will do some now. Okay. Then there are some properties that you need to know. If you have the same base as the number, like log x base x, that equals to 1. And this is a very important property because when you do log sums, you always work towards where you have the same base and the same number, because that reduces to 1. If you have log whatever base 1, the answer is always 0.
So log any base is 1.
Log any base with 1, the number is 1, is 0. Doesn't matter what the base is. And if you have a number to the power of a log, then the answer is that number of the power of log. Don't understand? You learn. I have k to the power of a log. Then my answer will be cancel the k, cancel the log, cancel the base, x. Okay.
So would they give us in that form?
Yeah.
So the case is not a coincidence that they're the same. They have to be the same. The base of the log and the
Yeah.
power.
The base of that log and the number, the base of the big number, must be the same. Then the answer is your x. Okay. You're not going to use this one a lot. Only the first two, but you have to know the other one. Right. These are just examples. The one thing that I need to tell you is, if you have something like this, log, and remember the base is a subscript to, oops, sorry, wat wou ek nou gesê? 5. You can work that out, okay, with your calculator. But if I give you this, log 2, There's no base. Then there's always an invisible base 10. So if I don't give you a base, it's always an invisible base 10. Okay. Now take out your calculator. If you look on your calculator, there are two log keys on your calculator. This one here is where the 10 is omitted. So that's only log 2. That one. But if I give you a base, you use that one with the 2 blocks so that you can put in your own base and your own number. Right. Let's do some examples. The first type of question is rewrite the exponential form into a log form. That means I give it to you as something with an exponent equals an answer. I want you to change that into the logarithm form where the word log is inside. So let's do the first one. 3 to the power of 4 equals 81. Rewrite that in logarithm form. You first write log. First write log. Okay? What do I write next? The 3. But you write the 3 as a subscript. That's the base. And then what do I write here as a number? 81 equals 4. Very good. The next one. 10 to the power of negative 1 equals 0,1. You first start with the word log. What is the base? 10. What comes after the base? 0,1. 0,1 equals negative 1. You're very good. You can also omit this one. So you can just write log 0,1 equals minus 1. The next type of question is rewrite from the log form to exponential form. So from this part to this one. So let's start with the first one. Log base 2 of 32 is 5. Rewrite that as an exponent form. What will that be? 2 to the power of 5 is equal to 22. Yes. This one.
2 to the power of 0 is equal to 1.
Yes. There is no base. So you put in a base and then it will be 10 to the power of 0 equals 1. Very good. Let's look at another type of question I can ask. Use your log laws and expand the following. Expand. Or solve. Or this is in your homework number 1, C. Okay, what can I do? How? With a plus. I split those with a plus. Oh yes. Oh, the memory of a fish. Then, yeah. Then you get the factorize, prime factorize 4 and 16. So that will give you 2 to the power of 2 and 2 to the power of 4. Now, can you remember I told you that we are working towards something that looks like this? Log 2 of 2. Log to the base 2 of 2. That will be equal to 1. Can you see here is something that starts to look like that? Okay. What do I do with an exponent? You multiply it at front. There you go. I'm working towards this. I want that. Therefore, the log base 2 of 2 is 1. And the log base 2 of 2 is 1. 2 plus 4 is 6. That's your answer. The last type of question is where you use your calculator. In these questions, you're not allowed to use your calculator. You have to show all your steps. All right. Yep.
I have a question. Why do you not just multiply 4 and 16 in this case? Because it gives us the same answer.
I wanted to show you how to use the rules, the laws, but you can.
So you take the power and you put it at the front.
Yep.
Is that a law, man? It's just like
That's a law. That's the third law. The one where you were asleep. You're your boss.
we just did this now. We don't look at
Okay. The last type of question. Can I have some silence, please? Calculate correct to 2 decimal places. This must give you a clue that you can use your calculator. The 2 decimal places. So which key are you going to use to calculate that?
The log with the subscript.
Yes, the log with the 2 little blocks. The subscript is 0.5. The other block is 17. So quickly type that in onto your calculator. Yes. Remember, when you work something out and I want you to round it off, first write the original answer and then do the rounding off. And remember, when you round off, it's squiggly equal signs. New news. Yeah. Have you never learned that?
I've never done it. I've never done this.
Okay, donkey.
Because when we write like let's say our answer, we make it one equal sign. Then we have to write the squiggly lines. We don't write squiggly lines, we write one equal sign.
Let's quickly give you your homework. It's exercise 5, the one that we did something now. Number 1 to 3. It should take you less than 5 minutes. But I want to quickly mark yesterday's homework, and then you can have 2 periods to do the homework.